Alright, welcome to this video. In this video I'm going to talk to you about the concept of comparisons. This is a very popular topic among multiple choice questions when they're trying to test your knowledge of both conceptual physics and then also dealing with numbers. Okay, so it's a qualitative and a quantitative mix. So this example right here is dealing with gravitational attraction, and it says two objects exert a gravitational force on each other of 450 newtons. What would happen to the force if one of the masses is doubled and the distance between them is tripled? So what I have here is a very basic gravitational question where I have two masses. Let's say I have a mass here and I have a mass here, and they're going to exert a force on each other that's going to be equal and opposite. Okay, that's just going in opposite directions because Newton's third law says that they have to be equal and opposite. So if this is this force here, this has to be just the opposite force here. Okay, so to understand what's going on, we need to look at the governing equation here. And so what I'm going to do is I'm going to go ahead and just write this out and show you the governing equation. So the force of gravity is equal to the universal gravitational constant times mass 1 times mass 2 divided by r squared. Okay, and what I'm going to do is I'm going to take different ratios here. I'm going to start out with the original problem right here, and I'm going to assume that all of these numbers are just going to start out as a basis of 1. Okay, so everything's going to be 1. That's my original number that I'm going to deal with here. Okay, so just assume g is 1, m1 is 1, m2 is 1, and the radius squared is 1, because this is going to give me the original ratio is just 1. Okay, in other words, if I wanted to find my original force, it's just 1 times 450, right? Because those are the ratios. Now I'm going to do a ratio by plugging in the new parameters here. What did they tell us is going on? Well, I have this mass here. One of the masses has doubled and the other one has tripled. So my new ratio now is going to be, well, I'm going to start out with 1 here for gravitational constant. One of the masses is doubled, so I'm going to double that mass. The second mass stays the same. And the distance between them is tripled. So that bottom distance is tripled now. So what's my new ratio here? Well, I have a ratio of 2 over 3 squared, which is 2/9. Okay, so what is my final force here? Well, I know my final force here, my force of gravity, let's say final, or the new one, let's just say, is going to simply equal 2/9 times the original, right? And what was my original? 450. Okay, because remember, I started with 450 here, but I doubled one of the masses and I tripled the distance. So that gives me 450 times 2, which is going to be 900 divided by 9. Okay, if I scroll down here, I'm going to get my force of gravity. The new force of gravity is simply going to be 100 newtons right there. Okay, so that's a very quick way to do comparisons. You don't have to make up numbers or plug in all these big numbers. Some people will try to start out with masses of 10, 10, 20 and radius, and then they'll actually put real numbers in. You don't have to put real numbers in. You just start with 1 is everything, and then you basically, if I doubled it, I type 2 or write 2 in here, and if I tripled it, I just write 3 here. That's the new ratio of the original. And then to find the new force, you just multiply it times the original force. That's it. It's about 200 newtons. All right, I'm going to post more of these examples as we go on, but it's important to master this concept because this concept of comparisons is everywhere in physics, particularly on the multiple choice. All right, that's all I got for this video. Thanks for watching, and I'll talk to you soon.